Everybody, it's Professor Mitchell continuing with chapter 11. Today we're looking at section 11.5, which is quadratic functions and their graphs. So you can see the objectives here, 1 through 5, basically all just graphing quadratic functions in various forms. I'm not going to read all of those to you. The good news is that you already know how to do objectives 1 through 3, basically, because it's what we went over in chapter 8. And this is SLOC, which is constructing graphs of inequalities, linear and nonlinear functions, and conic sections. All right, so speaking of objectives 1 through 3, recall from chapter 8 that the graph of y equals x squared looks like this. It's called a parabola. And recall also the rules for shifting graphs. You can shift a graph vertically by adding or subtracting a positive number onto the end of the function. And you can also shift a graph left or right by adding or subtracting a positive number right next to the x. And remember, this is the one that's a little counterintuitive. If you replace x with x minus h, it shifts the graph to the right. And if you replace x with x plus h, it shifts the graph to the left. All right, a little bit of vocabulary with quadratic functions. A quadratic function is a function that can be written in the form f of x equals ax squared plus bx plus c, where a, b, and c are given real numbers and a does not equal 0. So in any given problem, you will have specific values for a, b, and c. It won't look quite as alphabet soup as this. The vertex of a parabola is the lowest or highest point on the parabola. So if we just quickly flash back to this slide, this particular parabola y equals x squared has a lowest point. But if this parabola were, for example, upside down, then it would have a highest point. All right. And then the axis of symmetry is the vertical line that passes through the vertex. So let me go back to that other slide again and show you what an axis of symmetry looks like. Unfortunately, it will not let me do this as a dotted line. But in this case, your axis of symmetry would just be the y-axis. All right, it's the vertical line that cuts the parabola in half. All right. In this chapter, all of our axes of symmetry will be vertical. When we get to chapter 13, we're going to talk about sideways parabolas. All right, so that'll be a little different. But for now, your axis of symmetry is always a vertical line. All right, so I think we are ready to do a couple of problems. So I'm doing something a little different this time. I am just taking the homework right out of my lab. I have found in the past that students sometimes have a little bit of trouble, I don't know, just navigating the buttons in this particular assignment. So for many years now, I have just done these examples directly in my lab. So let me pull up problem number 3. All right, so here is my version of problem number 3. Yours will likely be a little different. It says, sketch the graph of the quadratic function and the axis of symmetry. State the vertex and give the equation for the axis of symmetry. And the function is h of x equals x plus 9 squared. All right, so the first thing they want is the graph. So let me actually switch over to my tablet. Actually, no, that's fine. We'll switch over to the tablet. I do have this function written down. All right, there it is. H of x equals x plus 9 squared. So let me just give you a little idea of what this is going to look like. We know that regular old y equals x squared looks something like this. And it has a vertex at 0, 0. So remember what we were just talking about a few minutes ago from chapter 8. If we replace x with x plus 9, that shifts the graph 9 units to the left. Okay. So that means the vertex of the new parabola is going to be at -9, 0. And then it's going to go up like this. It's going to have the exact same shape as the original parabola. So my suggestion, and you're going to hear me say this again when we get to objectives 4 and 5, just so you know exactly which points to plot, you can make a little table. And I recommend maybe 5 points, including the x value that represents the vertex. And I am going to put that value right in the middle. So if we have 1, 2, 3, 4, 5 points, all right, x equals -9 represents the vertex. So I'm going to put that one right in the middle, and I'm going to pick 2 values that are less than -9, like -11, -10, and 2 values that are greater than -9, let's say -8, -7. Okay. All right, so now if I make a few copies of this function, then I can fill in the values for x. So starting with -11, -11 plus 9 is -2, and the square of -2 is 4. So that is 1 point on the quadratic function. Next, we'll put in -10. -10 plus 9 is -1, and the square of -1 is 1. -9 plus 9 is 0. 0 squared is 0. And we actually already knew that -9, 0 was on this graph. And I put in -8. -8 plus 9 is 1. 1 squared is 1. So I want to draw something to your attention. Notice that the y value corresponding to both -10 and -8 is 1, all right? And that is not surprising when you think about it, because those points are supposed to be mirror images of each other through this axis of symmetry. All right, so I expect those to have the same y value. And in fact, I also expect these 2 points to have the same y value. -7 plus 9 is 2. 2 squared is 4. All right. So actually, if you're lazy like me, you don't really have to do both -10 and -8, or both -11 and -7. You can just do one or the other. And then the symmetry gives you the other point for free. So that's kind of nice. All right, before we go back to my lab, it is going to ask me at some point for the equation of the axis of symmetry. So remember, the equation of a vertical line always has the form x equals a number. So this is equation of axis of symmetry. All right, so now the only question is, what is the number? Well, in this case, the number is -9. The equation of this vertical line is x equals -9. All right, so now let me just do this. Oh, actually, this is not really going to work out all that well, but that's okay. You know what I'm going to do? I'm just going to write over, make this -2, -4, -6, -8, -10. I've got a lot of stuff going on between -7 and -11, so that scale is not going to work for me. -9, 0 is right here. And then we also had -8, 1. Oops. Here's negative 8 comma 1. Here's negative 10 comma 1. And then we also had negative 7 comma 4 and negative 11 comma 4. That would be right over here. All right, so using this scale, let me try that again. Takes a little bit of practice to draw a graph on a tablet. All right, I'm really good at doing it on paper or even on a real old school whiteboard. It'll look a lot better when we do it on MyLab. Okay, but I do encourage you to do these on paper first and then put everything in the computer. All right, so now I am ready to go back to MyLab. So we can put in all these answers, and you're going to want to pay attention to all the different buttons that I have to push. All right, so let's pop out this graph. Okay, the first thing I'm going to click is the Parabola tool right here. All right, and the first thing it's asking me to do is click the graph to plot the vertex of my parabola. Remember, the vertex was at negative 9, 0, which is right there. And now it wants me to click the graph to plot any other point on my parabola, just one other point. All right, it's definitely not enough to do it when you're doing this on paper, but on the computer it is. So I went up to negative 8 comma 1, and there is my parabola. All right, now you can probably see it a little better. Okay, the other thing that they wanted me to do was to graph the axis of symmetry. So now I have to go to the line tool, and it's saying click the graph to plot the first point on your line. For this, I usually just use the vertex. We know it passes through the vertex. And then for your second point, just use any point that is directly above or below the vertex. Remember, the line is vertical. Okay. So there is the axis of symmetry. Now there's one other thing to do, is they wanted this as a dashed line. So when you see that a graph is in yellow, that means that it is selected on the computer. And so if you click the dashed line button over here, it will change it to a dashed line. And now if I click out here, you should be able to see it better. All right, so don't worry, we're going to be doing this a few more times in this section if you didn't quite get every single step of that. Right now I'm going to hit save, and now I'm going to ask it to check my answer. Woohoo! It likes that answer. All right, so now the next thing it wants to know is what is the vertex. We're going to type an ordered pair. Don't forget the parentheses. I could use this button. And then I just put the negative 9 there and the 0 there. That looks good. And then finally, it wants to know the equation of the axis of symmetry. Be sure to include the x equals. And that should do it. All right. So let's see what we have next. All right. So the next example in the homework is number 4. They want me, it's the same problem. This time the function is f of x equals x minus 8 squared plus 3. All right. So let's switch over to the tablet. All right. So first of all, remember your regular original y equals x squared. Looks like this. So now we want to know what happens. First of all, if we replace x with x minus 8, that is a horizontal shift to the right this time. And then the plus 3 on the end is a vertical shift 3 units up, right? Okay. So that means that my vertex, which started out at the point 0, 0, is now going to be at the point 8, comma 3. Other than that, the parabola is going to look exactly the same. All right. So to get the particular points on my parabola, remember I like you to do the whole thing on paper first and then put it on the computer. I'm going to make my table. And you know what? This time I'm going to take my own advice. All right, I'm always thinking about plotting 5 points, but I'm going to use the symmetry this time to get 2 of them. Okay, so right in the middle, I'm going to put the vertex point, which is 8. And we already know that the y value that goes with that is 3. All right, so let's focus on getting 2 other points to the right of the vertex, let's say at 9 and 10. And then we'll use our symmetry to get the other 2 points. All right, so if I put a 9 here, 9 minus 8 is 1. 1 squared plus 3. 1 squared is 1. 1 plus 3 is 4. All right, so this point, let's say right about there, is 9, comma 4. So right away, that tells me, since the point that is 1 unit to the right of the vertex has a y coordinate of 4, so does the point that is 1 unit to the left of the vertex. Okay, so completely for free, I get that this point over here is 7, comma 4. And the same thing with x equals 10. 10 minus 8 is 2. 2 squared is 4. 4 plus 3 is 7. All right, so the point 2 units to the right of the vertex has a y coordinate of 7. So does the point 2 units to the left of the vertex at x equals 6. All right, see how much work that saves you when you use the symmetry? All right, so now going over here, and once again, I'm going to have to change my scale. Let's make each one of these worth 2. All right, so we know the vertex is at 8, comma 3. Actually, you know what? I'm also going to make these worth 2, because I remember I have 1 point with a y coordinate of 7. So we need to do it to both this time. All right, 8, comma 3 is right about there. 9, comma 4 is right about here. Because of the symmetry, I know I also have this point. And then 10, comma 7, that is right about here. Because of the symmetry, I know I also have this point. So my parabola ends up looking something like this. All right, so now I think we're ready to switch back to my lab. Fill in these answers. All right, so use the graphing tool. So remember what I did? I popped this out. I hit the parabola tool, the vertical parabola tool. We're not going to use this one until we get to chapter 13. Click the graph to plot the vertex. The vertex was at 8, 3. All right, and then click to plot any other point. One of the other points was 9, comma 4. So if I just go 1 to the right and 1 up, there's that. Okay, we're done with the parabola. But we also need the axis of symmetry. So I click on the line tool and make the first point my vertex, and the second point can be anywhere above or below the vertex. And then while this line is still selected, click this button to make it a dashed line. Okay. All right, so we should be good to go with that. I'm going to hit save. I'm going to check my answer. Woohoo! The vertex is 8 comma 3. And the equation of the axis of symmetry is x equals 8, right? All right, there it is.